Hello from me. I'm at our job site here where we're installing a dryer, just commissioning it this week in Heath, Ohio. And we did a CIP here yesterday, so a relevant topic for me. Makes it fresh for me, this discussion of ways to improve CIP on a spray dryer. So.
All right, I'm going to launch your presentation here on my screen, and you just walk me through when you would like me to advance the slides.
All right, thanks, Missy. So put that in run mode. There we go. We're on the title slide. And it's sort of a topic or two subsegments of the topic. You know, a better dryer CIP is both extending the run duration between CIP cleanings and how to shorten that CIP wash cycle itself. So we're going to sort of look at what plays into this and some common sense things for what we can do to improve it. A little commercial from us. This is the only sort of pitchy thing we've got here. If you don't know Caloris, we are a supplier of new equipment and upgrades for evaporators, spray dryers, and membrane filtration for the food, dairy, and beverage industry. So if you have any questions beyond this presentation, feel free to reach out to us. And then as a reminder, you'll get a link to this recording. Missy said that already. Feel free to use it. If you find this conversation helpful to you, please feel free to use this. You can always get to the video through our Caloris website. The recording of this webinar through the Caloris website, we'll leave it up there for years to come. And if it's helpful to extend conversations you're having at your company, please feel free to use it. By me saying this, you have our permission. Missy, go ahead. All right. And quickly to say, what is today's webinar not about? The one topic, one subsegment of it I'm not going to cover is the daily or somewhat daily cleaning of the dryer liquid feed system, so the high pressure line or the line up to your rotary atomizer. That's a topic for another day. What we're really talking today about is your spray dryer CIP, the CIP cleaning of your chamber, cyclones, fluid bed, ductwork, etc. So there we are. Missy, go ahead. All right, and you know, the measurements, the sort of modern measurements of you know, operational efficiency are OEE. So what are we trying to do? We're trying to improve OEE, so that's overall equipment effectiveness. Missy, go ahead and click twice. Thank you. And what we want to do, the two areas we're going to attack is you know, what can you do while you're running the dryer? What can you do between CIPs to make sure you're getting less buildup? All those sorts of things, so you don't need to CIP as frequently. And then how can, once you are in CIP, how can you shorten that? Missy, go ahead. So how long between dryer CIP cleanings? What can be your expectations of how long you could actually get? And I sort of looked at this in three ways, because there's different things that get produced, different powders that get made have different outcomes, different needs. So Missy, go ahead, click 3 times. I can just run through what comes here. So I looked at it from a standpoint of commodity products. If you're running the same thing all the time, maybe you're running like a dairy product, like a whey protein or a skim milk, maybe you're running a plant protein, but these kind of things where you're running the same or a very narrow band of products all the time. We might say, you know, a good target is 3 months. We're seeing a lot of plants, a lot of spray dryers run maybe a year between CIPs. So if you're trying to set yourself a target out ahead of yourself to improve towards, we are seeing people maybe CIPing a commodity dryer every month, and they could try to extend to 3. We're seeing some that maybe are getting to that 3-month edge, and they could strive to go for a year. But what I'm trying to tell you is that, you know, the 180-day target, the year-long target is out there. That is being achieved. And when you do that, what would be a reasonable duration for the CIP? How long would it take you from off product to on product again? You know, if you're reaching that long target of a year, boy, it's not unreasonable to think if the CIP is working well, the machinery is working well, and the cleaning is effective, to get turned around in 12 to 36 hours. If you're really getting out to the year, I don't think 12 hours is quite so possible. Maybe if you're in the 3-month range, the 12 hours is possible. But 12 to 24 hours in that span, maybe up to 36. And if you're out longer than that, now, please know if you're using your infrequent CIPs to do maybe bag house changes or other housekeeping or other maintenance issues, you may extend your CIP out longer than the CIP itself calls for. I get that, but we're seeing people out there that are on a commodity product which should be easy to clean, taking 5 days or longer to turn their dryer around. So we just want to set a good expectation. When you talk about campaigned products, so the kind of thing that are batch formulas of nutritional formulas, maybe that's infant formula, maybe it's animal feed formulas, maybe it's a coffee whitener, things like that. A little bit wider range of products, maybe with some special ingredients that are either sticky or fat-filled or the like. We're seeing people run 4 to 12 weeks between CIPs. At the tough end of that, people we might say should be able to get 4 weeks are only getting 1. Some that could get longer are, that could get up to 12 weeks in between CIPs are only getting 4. But we're saying on this range of products, 4 to 12 weeks is good. With durations, again, green smiley face next to the CIP duration, that a CIP could be turned around in sort of 8 to 16 hours. If all the equipment is there, made to run automatically, and it's in good working order, the chemistry is right for your cleaning chemicals and all of the rest, a good tight target could be 8 to 16 hours. On the long end of the spectrum, we're seeing people struggle sometimes where they're CIPing once a week and it's taking 36 hours because equipment's not automated, the programs aren't running well, the machinery's not well maintained. So it's both ends of the spectrum there. And finally, specialty products, flavors, or various specialty ingredients. We're seeing people CIP as often as 10 to 40 times per month, 2 to 5 times per week on a dryer. And that has different drivers. That's allergen classes or flavor segregation or things like that. They're not running their dryer poorly. Their product requirements drive them to CIP that often. But they could be CIPing in as little, turning around from off product to on product in as little as 3 hours, 6 hours, maybe 8 hours, depending on levels of automation. But we're seeing people struggle with needing to CIP that frequently and having it still take 16 hours, 24 hours, up to 36 hours because of lack of automation or lack of maintenance of CIP systems. So one other thing I'd want to say about this slide, it's the people on the commodity end, the operators, the plants on the commodity end that have extended CIP. They teach us about the best operational practices to get the longest duration between CIP. We have things to learn from them and apply it across the other classes. The people who live in the specialty products world where they're CIPing very frequently, they're really trying to press down the CIP time. And that's informing us of how we can take those lessons and apply them to the campaigned products and the commodity products. So it's there's lessons to be learned from each group and applied to the others. Thank you. Missy, go on. All right, and click the next. And click the next, please. All right. So when we're talking about OEE, overall equipment effectiveness, and we're trying to extend the duration of CIP, let's talk in terms of if it's a commodity type product like we're showing. Let's say you're running 30 days, you're trying to extend to 60 days. And in that same regime, we want to shorten the wash. Let's say you're running 16 hours, we want to get it down to 8. What does that mean overall? Where does the opportunity lie in that? So Missy, one more click. Well, what that means is you're right now, 12 CIPs a year on a 30-day interval, 16 hours per CIP is 192 hours for CIP. You cut each of those, so you go from 30 days to 60 days and 16 hours down to 8 hours. Now you've reduced from 192 to 48 hours. So you've gained 150 something hours a year, nearly a week's worth of running hours or 2% of your year. What's that worth to you? So that's a rhetorical question only you can answer based on your product's value and your plant's economics. But what would you do? What would you spend or invest in equipment or training to gain an extra 150 hours of operating time per year? So next slide, please. Next 2 clicks, please. So now on the other end of the spectrum, like the specialty products, So if you need to wash, you just need to wash. So if you were washing 10 times per month on a specialty like a flavors product, you're still going to wash 10 times per month. But what if you could reduce that? What if it was taking you 12 hours and now it takes you 6? Next click. That has you at 10 times per month at 12 hours per CIP. That has you at 1,440 hours per year of CIP time where you're not on product. You cut that 12 hours down to 6. You've cut out 700 hours of CIP time that's now able to be used for production. So again, the question is, what is that worth to you? What would you do in training or equipment improvements or the like to capture some of that as operating hours? Missy, go ahead. Next click. So again, a little bit of my answer to that rhetorical question, because I don't know your exact operation, but if you're in that commodities arena and you're running 5,000 pounds an hour and you're getting that 140 extra hours per year because you've taken those steps, $1 a pound, that's, is it profit? Is it net margin? Well, I think if you get a few extra pounds, most of that goes to the bottom line. Your overheads for your plant are covered. So click, please. That adds up. 5,000 times $1 a pound times 140 hours a year, $700,000. That's the potential value, simply put, in capturing that extra time. And again, the question is, what would you do in procedures or procedure preparation or training or equipment to realize that extra operational potential? Next 2 clicks. Same on the other end of the spectrum. If you were in that sort of specialty products, maybe it's a smaller dryer, 500 pounds per hour, but now you're talking about getting 700 hours per year. Now my $1 per pound is maybe a little conservative. These flavor products might have a net added value of $5 a pound or something like that. But at a conservative $1 a pound, again, $350,000 per year potentially captured in extra throughput of the plant. Because you've improved the CIP. So that's the potential that lies there. That's how we look at it. Now comes the what do we actually do to capture this? So next slide, please. So again, one more or a couple more slides on background. 4 clicks total. One more. There we go. We'll hold on that. Thank you. So why to clean the dryer? There's actually 4 drivers in my view that sort of aggregate to be the reasons you clean the dryer, your spray dryer. One big view on product quality, but different reasons for your finished product quality. The first could be discolored particles or burnt specks. If you're getting to that long end of the time, 3 months, 6 months, a year, your product in the chamber is going to be exposed to temperature and it might discolor. So that might be a driver, that product quality visually with burnt specks might be a driver to clean your dryer. Again, the flavors folks, the ingredients folks who are batching things, there might be product segregation issues, product separation, so colors or flavors. And nowadays, very strong view on allergen classes. In the US, we have 8 allergen classes. The EU defines 14 different classes of allergens. Could be a driver to do these CIPs so you get full segregation between your products. Obviously, biological contamination could be the 4th one. And spray dryer safety. So chamber buildup, whether it's burnt on, showing you hot spots, or you have layers of buildup, which could, in certain cases, depending on your product characteristics, auto-ignite and start a fire. We want to keep an eye on that chamber buildup and chamber buildup. Or cyclone buildup or other vessel buildup could be a driver to cause you to do a CIP. But these to me are sort of the drivers of why we need to clean and what makes that decision. Can I go another week? Can I extend it by another month? To me, it's asking questions, both in operations and in conjunction with quality people to make sure you're still putting the same good product out the door. Missy, 4 more clicks. And I've categorized these 4 areas into what we can do. The 3 red pop-ups there are, what can we do to reduce or prevent the thing from happening, the biological contamination or the chamber buildup? Well, we do that on the operational side. You do that in your running hours. You run your dryer better so that you can CIP less. In the product segregation, we just have to accept that the nature of the production requires this, and we're going to have to design an effective CIP so that we can CIP in the fewest number of hours possible when you're going to CIP many times per week or month. So, Missy, next slide. Quick look at just put it in here for reference, the 8 US allergen classes. Just a quick look up on the internet finds you these again, but these are the drivers for a lot of things these days that have to do with CIP, as these batched formulations with mixes of dairies and glutens and nuts become more prevalent. So next slide. So into the meat of this, how do we, what are things we can do, common sense things to do to extend the duration between dryer CIPs? Next slide. All right. So one of the product quality things I mentioned previously was the buildup on the dryer, leading to burnt specs or biological contamination or safety concerns. What's causing those? How can we minimize them? Well, unsteady or regular startups or shutdowns. So turning your dryer on, going from idle and spraying no product to spraying product, and then going from spraying product to shut down, so spraying no product. That would be, I think, the single biggest potential time to create an upset condition that could wet the chamber down or heat the chamber up, dry it out, causing burnt specks, wetting it down, causing buildup. If the startup and shutdown can be done in the most repeatable way and the most controlled way, you have the easiest startup and therefore the least buildup, the least problems. So if we have unsteady regular startups and shutdowns, I put the little red unhappy face there. That can be problematic. Manual startups, many plants, we have a lot of old plants there that people are very successfully keeping running, but they don't have the automation. So the day operator may start the dryer differently from the nighttime operator. Any one operator may have various other things that he's keeping an eye on, and he's he or she is not able to make the startup the same every time. So if the opportunity presents itself for an automated startup, so getting your product from your dryer from idle to running, spraying with all its nozzles automatically with very controlled ramp speeds. I'm not saying slow ramp speeds. I'm saying very controlled, very repeatable ramp speeds. Same with product changeovers or shutdowns. And then I'm going to introduce a word. I don't know if I'm making this word up, but it dawned on me as I was preparing this. Automation maintenance, that reversion to validated programs. This used to work. We used to run the automated program a certain way, and now it doesn't run that way anymore. Somebody changed parameters, and it doesn't run the same anymore. And therefore, it's just a little messier of a startup, a little more spray in the chamber, a little cooler outlet temperature that makes the chamber a little moister. So once you have a validated program, remaining or being able to revert to that validated program is a thing to keep an eye on. So a good startup, a good shutdown program that's been validated to be the most steady, the most repeatable possible is an important start on effective operations leading to minimum buildup. Proper spray nozzle selection, I'll cover that in the next slide, making sure you replace nozzles when they're worn. If you don't know what that means, do please investigate that. Nozzles wear out. There are tools available from the nozzle manufacturers to test them. You wouldn't be able to visually tell that the open area of one of these very small nozzle orifices is 10% more open area. One needs a specialized gauge to look at that. If it's 10% more open, it's behaving differently. The nozzles need to be replaced with some regularity to maintain this quality control of your drying chamber. We also want all the spray nozzles spraying in a generally symmetric pattern. Walked into many plants. It may be a 6 nozzle dryer. We're only running 5 nozzles. Well, why are you only running 5 nozzles? Well, we're not, don't have the volume today. Well, could you change the orifices so that each orifice is a little bit smaller so that you can run all 6 nozzles and maintain a symmetric pattern? Then you don't have hot spots where there's no nozzle and cold spots on the other side where the sprays are in a normal way. So using all the spray nozzles in a symmetric pattern is an important part of good effective operations when it comes to extending gaps between CIP. I've seen I've seen plants and spray dryers stop the maintenance or the use of their feed filters, leading to some clogging of filter or clogging of nozzles. If you don't have the feed filters in, you're not maintaining them, you're not changing them with regularity, or you've just taken them out of line entirely. The small particles that undissolved particles or things like that can get up into the nozzles, clog them. So I would say my experience walking into some plants is there's some that have abandoned their feed filters. Do make sure that those are still in there. They are there for a reason. Another topic I'll cover in another slide is I'll call it Goldilocks airflow. Your dryer and its air disperser were designed for a certain airflow. Not too much, not too little. We can adjust temperatures, but we shouldn't be adjusting airflow rates. We want to maintain the Goldilocks airflow. Missy, next. So a little bit more on automated startups. So starting your dryer using a modern HMI if you have it in a controlled way, so that you push a button and all your motors start in sequence and all your fans ramp up on a controlled, measured, programmed ramp. That automation leads to more consistency, and more consistency leads to less buildup in the dryer. Less buildup in the dryer leads to longer times between your CIPs. So I'm hammering automation hard, but it's not just that you have it, that it's actually been commissioned to be the best startup sequence or shutdown sequence that you can have. You'll have emergency situations. You'll have to shut things down quickly. There will be some mistakes. Maybe a fan belt will break and there'll be a problem. Those can't be avoided. But your regular automatic startup and automatic switch onto product, if you have that capability in a good, maintained, tuned, commissioned way, is going to get you that best startup with least buildup. If you don't have that, that's the opportunity to improve your operation. Missy, next slide. Thank you. Again, proper spray nozzle selection. I've chosen on the right-hand side of the slide there to say, a couple of good companies are Delavan. Maybe you have your nozzles from Spraying Systems. There are other good manufacturers out there. Beat from Europe, Click and Dry. I really don't play favorites one over another. They are all effective for spray drying. I would say as I said before, one of the more important things is that symmetric nozzle lance pattern. Let's use an example where you have 6 nozzle lances in there. Again, if you're using 5 with very regularly, I mean, if it's in startup and you're working your way, or today, maybe you're only running 5 because you've got light solids or something like that. One day is okay. But if you're consistently only running 5 when you have 6, it's time to consider whether you should be running a smaller nozzle orifice so you can run 6 and get the symmetric pattern that gives you even drying, even airflow, and eliminates the hot spots and the cold spots in your dryer. As well, I've walked into the dryers, this is just fine. They'll put 3 nozzle lances on one size orifice and 3 nozzle lances on another size orifice, so they can get a bit of a balance between 2 orifice sizes, perhaps. Well, you want to put them around evenly, large, small, large, small, large, small, as opposed to putting 3 large on one side and 3 small on the other. A symmetric nozzle lance pattern, for whatever the reason, is going to get you the least amount of buildup, your cleanest dryer. Spray angle is also important. That gets a little touchier to select those, requires a little experience. Senior operators probably have good experience at that. If you've risen up to be a supervisor, a plant engineer, or the like, you probably got a chance to have some experience with the spray angles. But if you don't and you need some help, the nozzle manufacturers have application specialists that can help you with that. They may engage someone like myself or one of my colleagues from Caloris to work with them, so we can talk about both the nozzles and the spray dryer together holistically. But the nozzle manufacturers do have good application specialists. If you're working with one nozzle manufacturer and you're not getting the answers you want, it's not the hardest thing in the world to change. Spraying Systems is, they have some some aspects that are different from Delavan. In the biggest picture, I think good service is important. If you want to switch nozzle manufacturers, there's nothing that magical. I'm sorry if we have any folks on with us from the nozzle manufacturers. In the biggest picture, I would go with the company that gives you the best service. Everything else can be made up in the nozzle selection. So again, work with their application specialists. They're out there waiting for your questions. You know, if you have cone buildup in your drying chamber, then I'm saying wider nozzle angles. Get your sprays out a little wider into the chamber. Generally, if you have wall buildup, especially high in the chamber, then maybe you could do with a little bit narrower nozzle angle. Your swirl chamber inside of your nozzle would change in both those cases. But weigh these changes carefully. Your customers have gotten used to your product. Maybe it's a agglomerated product, whatever it is. Weigh the changes you make carefully. Do it scientifically. You know, note the changes you're making and then measure the product afterwards. Measure the outcomes. So, Missy, next slide, please. A couple of minutes on your air disperser. Any dryer manufacturer, whether that's Caloris or any of the others out there, have designed your air disperser to match the design airflow of your dryer. There is a velocity in the throat where the air enters the drying chamber around the nozzles. It's always best to be running at the design airflow. Okay, plus minus 10%. But if you're running at that design airflow, you're going to get a correct differential pressure, and you're going to get correct air distribution, a nice even airflow downward. If again, in my experience walking into some plants, they have a product, maybe they need less throughput on that product, and they'll reduce the airflow. Please don't reduce your dryer airflows to reduce your product throughput. Reduce your temperatures, reduce your inlet temperature, and then balance your outlet temperature to get the product moisture. If you need to reduce throughput, don't do it with airflow. The same to the other side. Be very careful about increasing airflows to increase air throughput. It may be possible. It should be done by a specialist. One should always be concerned about spray dryer safety. But too much airflow could drive the product down deeper into the cone of the product. You'll have a higher velocity. It'll push it down further into the cone and could increase your buildup. Your air disperser and your airflow were chosen by your dryer manufacturer for a reason. So if you have questions about those, please bring them up in the chat part of this. We'll handle all the questions at the end. And I have shown my email address at the beginning, and I show it again at the end. If you have any questions that you want to ask outside of this, you can write to Caloris or you can write to me, and we'll help you, at least give you an opinion. So Missy, next slide, please. All right, so that's some thoughts, not a comprehensive list of everything you can do to prevent buildup and extend the time between your CIPs, but some ideas and some areas that we see getting less attention than they should to extend those. So the next bit of this, the last bit of this is you know, shortening the dryer CIPs themselves. So let's go on to the next slide. All right, the easy things. I feel bad putting this in here, but we want to make sure we say everything. If there's someone who this is new for, well, then I'm glad I've put this in here. So CIP is really, I'm thinking about from the minute you shut off your feed pumps and you stop spraying in your spray dryer, you're off product. You set your dryer up for CIP, you make some changeovers, then you're going to do the CIP wash, then you're going to change it back and set it up for production, and then you're going to warm everything up, dry it out, and put it in production. Well, it's a little bit the thing about trying not to fix your roof while it's raining, that old metaphor, not fix the roof of the house while it's raining. The things you can do to make for a good CIP, a lot of them can be done when you're running. So while you're still running, you know you're going to do a CIP in 2 days or in 5 days or whatever, making sure you have all those tools, all the swing connections, key pieces, whatever that you're going to need. And that anybody you've hired new since you've done the last CIP, if it's been 3 months or a year since your last CIP, boy, it's, you know, finding those tools, finding those pieces, and making sure everybody understands the objective is sometimes forgotten in the heat of the moment of trying to get production through. CIP systems, the CIP kitchen, so where your tanks and your pumps are there are often filters there. making sure those filters are in place, making sure those filters have been cleaned out since the last CIP, so we can get the maximum flow through, and again, making sure that they're in place so that your CIP nozzles don't become the filter and become clogged up with material or gunk. Checking all the nozzles you have. If you're fortunate enough, you have a modern dryer with automatic nozzles, checking that they work before you go into CIP, making sure that they stroke, make sure the air is connected, make sure all the solenoids are working, all your sanitary valves, your CIP pumps, the heat exchangers, making sure all hand valves and the steam system are open. Do you have, really, I'm telling you things you know, but do you have the checklist so that if you had a new employee next week and you had to do a CIP, do you have that all clearly identified? It's great if you do. Many plants do. I'm not saying the majority don't have this, but there's still plenty out there that could do this. Again, also clearly identify the sequence of tasks, the procedures that you do. Make sure you have the documentation. Make sure you have had the chance to do the training. The challenges, where are there opportunities is really what I'm trying to say when I use the word challenges. Could you, again, to capture that financial benefit of more available runtime, do you have all the automated or toolless setup? So when you do this changeover from production to CIP, do you have the features in your rotary valves so that you could do a toolless setup? Could you run CIP through your rotary valves? Are they the type with the shaft seals that can handle that? Do you have easy to put in place, easy to take out of place CIP isolation plates so that if you have to blank off a duct, it can be done in the easiest, fastest way possible? Even that can be automated with cylinders in some cases and the like. Would you spend money? Would you spend some of that potential recovered money on sanitary valves instead of swing connections so that you can get into CIP and back from CIP a whole lot faster? And then, it's been in the last 10 years through this kind of thinking process that CIP-able sifters have been developed so that both manpower and time don't have to go to the manual cleaning of some of these items that are out there. And that's just a short list of some of the opportunities of what one can do to automate the changeover from production to CIP and CIP back to production. Missy, go ahead. Thank you. Automated nozzles versus spray balls. The classic spray ball still has a place in spray dryers. Not to worry, they will be there. Even if you're trying to do the most automated CIP in the very shortest amount of time possible. The new dryer, that I'm at right now, where we're commissioning right now, where we have a lot of automated nozzles. I have 70 or 80 automated nozzles on the dryer. There are certain places in the dryer, like the underside of fluid beds, where a classic old, simple, easy to maintain or no maintenance spray ball does the job. But there's a lot of dryers out there where the first thing one does when one wants to switch into CIP is manually install 80, 100, 120 manual spray balls like are shown on the left side of the screen. Would one benefit? Could one justify the implementation of, automatic pop-up, air to open, air to close CIP nozzles? I'm showing two brands there on the right. There are other brands. Again, no favorites in this. We just think at Caloris, with our experience with spray dryers, that there's a lot of time spent on manual installation of spray balls where there could be automatic deployment. And hours per year, tens of hours per year, could be recaptured for operation. It's a capital cost once, but it's a time cost with each CIP. Go ahead. Again, another area in the CIP kitchen. Lots of spray dryers out there, especially the ones that CIP infrequently, where it makes sense to have a one-tank CIP system. So you fill the tank and you heat it up and you do a rinse, and then that's emptied, and then you fill it up again, and that takes some time, and then you heat it up again, and that takes another 30 minutes, and then you wash and you add some chemicals and you empty it out when that's done, and you go through your many cycles, losing a fair amount of time to filling, heating, and emptying. Extra hours are added in. Now, if you only CIP once a year, or once every 3 months, that's fine. But there's a lot of repurposed dryers. A dryer that was maybe a dairy dryer designed originally to CIP every 3 months, and now it's repurposed for something else. The one tank CIP system is then a legacy item, and there are better ways to do it. Would adding a second tank save hours of filling and heating time? The most modern way is a 4-tank CIP system, so that you might have a pre-rinse tank, a caustic wash tank, an acid wash tank, and a final rinse tank. You could be washing multiple dryers. If you have a site with multiple dryers, you could be washing multiple dryers with no queuing. Having a 4-tank CIP system like this. If you're in the type of plant we talked about earlier, a flavors plant, where you're looking at turning around in the very fastest time possible, you're really trying to achieve that 4-hour CIP turnaround time from off product to on product, well, then this is an absolute necessity. High capital cost, but very much time savings. Another area that can be looked at as one washes more often, as one has the potential 4-tank CIP system, is chemical reclaim. So cleaning up your caustic tanks. So if you're washing multiple times per week, you essentially have cleaner caustic with last week's washout gunk cleaned out of it, ready to go. So chemical reclaim is becoming much more cost effective these days, with the increasing price of chemicals and the decreasing price of the filtration necessary to do it. So next slide, please. So CIP methodology, again, as you're maybe trying to think about these improvements, you have an automatic CIP program, and I'd still like to, you're thinking, I'd like to cut the time in half. How do I get down from my setup's good, I need to get down from 8 hours of washing time to 4 hours of washing time. Well, there's the CIP methodology. Generally, when there's been automated nozzles in a big dryer, it's been a rinse and soak methodology. You spray in one area, let's say your drying chamber outlet ductwork, you spray in that area for a minute. Then you stop spraying there, you let that soak, but you start spraying in your cyclones. Then you spray there for a minute, you stop spraying there, and then you spray in your fluid beds. A dryer may have 10 zones like that. So it's spray for a minute, 9 minutes of spraying elsewhere while it soaks, and then coming back and spraying in the first area. Fairly effective. I mean, it gets the dryer clean. You have those smaller tanks and pumps, so you don't need the largest volumes of water, but it does eat up time. It is not the most time effective way to wash your spray dryer. So I'll call it a rinse wash, where you're rinsing, washing as much as possible. Sure, it takes big tanks. Sure, it takes big pumps, large volumes of water. You can hold them afterwards, trickle them back into your wastewater treatment plant so that you don't overwhelm the floor drains and then the wastewater treatment plant. But if you're looking to get that CIP turnaround time down, especially in those sort of campaigned products, like I was saying, nutritional formulas, fat-filled products that you're batching up, coffee creamers, where you might be running or CIPing once every 2 weeks, once every 4 weeks. This is a way to get that time down, the thinking of bigger tanks, bigger pumps, to claim back those hours for production. So, Missy, next slide, please. So, last topic, a little bit of fun, lighter moment. Wanted dead or alive, the person who extends CIP timers and doesn't set them back. If I were in a plant every day, boy, I would give a bounty for that. Now, there's reasons to set CIP timers longer. Oh, you've had a spray nozzle break this week, and you wet down the drying chamber. It has more buildup than normal. So let's make the caustic wash last an extra 30 minutes. But then nobody sets it back, and it becomes the new de facto standard. And the next time something happens, somebody sets a different timer, 30 minutes longer. I can't tell you how many times Caloris and my colleagues have gone into plants where we know a particular set of steps in a CIP should take 4 hours, and we're finding that it takes 7. And when you ask the question, why does it take this long? Nobody can really answer it. They can say, oh, we used to do it in 4, and we set some timers longer, but we don't really know, and I wasn't on the shift then, and all the rest. To know again, this is what I said earlier about automation maintenance. Know your base program, know your base timers, not the programming that you need a specialist PLC programmer or HMI programmer to come in and do. Know the base set of timers. We do caustic wash on this dryer for 75 minutes, and then we do a 12-minute rinse, and then we do a 30-minute acid. Know that base program, just like you know your inlet temperatures and your outlet temperatures and how you run those things. Document that and always revert back to that so you can justify each time why you might need to go longer. You may need to go longer. That's why you have the flexibility in the timers. But do be diligent about that. We've seen lots of plants suffer from the extended timer that never gets set back. So one more, hammer home on that on one more slide. So CIP duration, and it applies to all unit operations in the plant. Losses due to extending timers. I really feel it. I could bring 5 more colleagues of mine onto this webinar, and all of us would give you a litany of experiences saying that extending timers is the #1 problem in achieving OEE. We'll just do it a little longer. 30 minutes worked, 40 minutes is better. In 3 months, then 40 minutes is fine, 50 minutes is better. And before you know it, things take hours longer than they used to. You ask someone in the factory, and then we might get the response, the system didn't come clean for whatever reason, because we broke a high pressure nozzle and sprayed the chamber. So I'll extend the caustic wash time by 90 minutes. Next. And it was, we never find the person in the plant. It's never said by anyone, and I will reset the timer to the original standard, because maybe there's not a standard, or they're not held accountable for extending timers, and the time grows. So click, please. So we're constantly finding these CIPs that were designed to be done in these lesser times sequences. It's as true for evaporators as it is for dryers and membrane filtration and anywhere else in your plant. We constantly coming in finding CIPs that should take 4 hours are now taking 6 hours, 8 hours, or longer for no reason that can be justified for the general CIP, for the average CIP. So click, please. Again, we're also finding constantly poor maintenance on the CIP nozzles. So if you have these types of automated nozzles, the PM program, that preventative maintenance program that goes around and says, all right, we're gonna do CIP in a month. We're gonna start taking out nozzles, checking that they're unclogged, stroking them open, stroking them closed, seeing that they operate so that when we get to CIP, we can run the CIP as quickly as possible. One could be doing that when one's doing the feed system CIP daily, just checking all of those nozzles, so that you're not doing it while the dryer's running. I know there's a hesitation to doing these sorts of things while the dryer's running, but checking of all of those CIP parts. Next slide, or next click, please. And then another one that's become more and more prevalent: dry out steps. When I started in the industry now too many years ago, you finished a CIP and you turned the fans on, and as quickly as you could set the dryer up for CIP, maybe an hour with 2 or 3 people, the dryer would be dried out. It's in the name, it's a dryer. Sorry to be flip about that. But the dryer would be dried out. Maybe there's a drop here or a drop there of water, but it is dried out, and it is sanitary and hygienically dried out. But there has been a push to sanitize with heat more and more. Again, the type of thing, we do it for 30 minutes, let's do it for 60. We do it for 60, well, let's do it for 90. We had a QA problem this week, well, we're extending it to 120 minutes, and now it's out to 2 hours without real scientific justification. That's where the opportunities lie to claw some of these hours back. I'm not saying run your dryer in an unsafe way for your company or your customer. What I'm suggesting is quick decisions are often made to try to do it better, like we'll extend from 30 minutes to 60 minutes. But then the scientific justification isn't followed up. It's only the anecdotal evidence that now we've done it 60 minutes and now we don't have a bacteriological problem, perhaps. But they may not be linked. They may not be causal. Because you had many times where you didn't have bacteriological problems and you only did the dry out step for 30 minutes. So we're really challenging you as interested parties and the plants we go to. really just work to justify, put some good science in, and justify those dry out steps that you're achieving what you want to, because otherwise you're just giving away time. Missy, go ahead. So with that, I want to say thank you for whoever's lasted through this one. Really appreciate the interest. I hope you found little nuggets in here that you might find helpful or spark thinking that, or validate thinking you yourself have already had. You can feel free to reach out to me. And there's the info@caloris.com email address. You can reach to Missy that way, and look for this on the caloris.com website. So Missy, I'll turn it back to you, and we'll take any questions that anyone has.
All right. Thanks, Jim. I don't see any questions yet, so I'm going to give folks a minute to enter in questions using the Q&A feature if they would like to. And in the meantime, I'm going to bring up the announcement you saw at the beginning, which is for next week's webinar. That will be hosted by Gary Maxon, our membrane system specialist, and it'll be an overview of an installation of an RO condensate polisher we did at a milk powder plant. Let me check the Q&A here. As you can see, you can register for that webinar at the URL on your screen, caloris.com/caloris-webinars. And that's also where you can find recordings for all of our past webinars and the schedule for upcoming webinars. If you want to be the first to know about webinars as they are scheduled, I recommend joining our mailing list, which is available by scrolling down to the bottom of any page on our website and entering your email where prompted. We only send out one email a week. It's an industry e-newsletter with topical headlines and resources for plant managers, in addition to announcements like our webinar schedule. If there are any questions you want to ask outside of the webinar setting, as Jim mentioned, you can send email to him or to myself, and that info@caloris.com address does go directly to me, so feel free to send us an email at any time. And we also are seeking your suggestions for future webinar topics. We really enjoy offering these sessions to you, and we would like to see what you want to hear about. We do have one question, Jim. Any insight on inspection before CIP to identify operating issues?
No, that's a good question, but a hard one about inspection before CIP. The best thing you can do is prevent problems, right? Prevent nozzle spray issues, nozzles being put together incorrectly. Personally, I'm a big advocate of testing your high pressure spray lances under pressure before you put them in the dryer, so that you don't have issues. That's both a safety concern, but this sort of operational concern. But it's you that could build up data. You're the one. If you have it in your plant, you would have access to the trends and see, what does the last 20 startups look like? What does the last 20 shutdowns look like, or all of the startups and shutdowns between since the last CIP. It's really an analysis of the data that would lend the insights. I think a visual inspection would tell you how dirty it is, and an experienced person could guess at how maybe you need to extend CIP timers. But I don't have much insight beyond that. So thank you for the question, though.
All right. Well, I don't see any other questions, so I'm going to go ahead and wrap this up for the day. We hope everybody has a nice holiday weekend, and that we'll see you on a future webinar.